Okay, Wildcat, so we're going 5. 16 tons, and what do you get? Solving work, mixture, and distance and cost problems. The student works 1, 2, and 3. Let's take a look at the next page. All right, go ahead and mark this page out. Let's take a look at the next page. Activity 5.1, solving work problems. A work problem involves the rate of several workers and the time it takes to complete a job. For example, the rate at which each of the two painters works, the total time it takes them to paint a house while working together, is an example of a work problem. Anita and Martin are the assistant managers for the marketing department of the Snarky Larks hockey team. This hockey season is fast approaching, and the rink board ads need to be mounted to the rink boards before the season begins. Each ad is like a giant vinyl sticker that is stuck to each rink board along the inside of the hockey rink. It takes a team of 3 people to attach each ad. 2 people hold the ad while a third person presses it to the rink board, being careful that it does not wrinkle. Up until last year, Anita's team and Martin's team have taken turns doing this job. Anita's team attached the rink boards for the first season. Martin's team attached them for the next season. The following seasons, Anita's team attached them, and so on. All right, let's take a look at the next page. It takes Anita's team 20 hours to attach all of the rink boards, and it takes Martin's team 30 hours to attach all of the rink boards. This year, however, their boss has asked them to work together to get the job done faster. 1. Determine the portion of the rink each team completes in a given number of hours. 20 hours, Anita's team. So that's 1 hour is 1/20 of the rink. 5 hours is 5 divided by 20, which reduces to be 1/4 of the rink. 10 hours is 10 divided by 20, which reduces to be 1/2 of the rink. 30 hours, Martin's team. 1 hour is 1/30 of the rink. 5 hours is 5 divided by 30, which is 1/6 of the rink. 10 hours is 10 divided by 30, which reduces to be 1/3 of the rink. All right, let's take a look at the next problem. 2. Consider the amount of the rink that each team can complete in X hours. A. Write an expression to represent the portion of the rink that Anita's team can complete in X hours. The expression is X divided by 20 of the rink in X hours. B. Write an expression that represents the portion of the rink that Martin's team can complete in X hours. The expression is X divided by 30 of the rink in X hours. 3. Each team's rate of work is defined as the number of jobs completed per hour. In this case, the rate of work is the number of rinks completed per hour. A. Determine Anita's team's rate of work, which is 120 rink per hour. B. Determine Martin's team's rate of work, which is 130 rink per hour. Right, let's take a look at the next page. 4. Complete the table. Portion of the rink completed. Anita's team is X divided by 20. Martin's team is X divided by 30. So the entire job, or one rink, is X divided by 20 plus X divided by 30. Rate of work. Rinks per hour is Anita's one team is 1/20th. Martin's team is 1/30th. And you can mark this box out. All right, go ahead and complete the table. All right, let's take a look at 3. Consider the expression from the table that represents the portion of the rink that Anita and Martin's team can complete when working together. If you want to determine the total time it takes the two teams to complete one rink while working together, what should you set the expression equal to? I'll set the expression equal to 1 because it represents one completed job. 6. Write and solve an equation to determine the total time it takes the two teams to complete the rink. All right, so our equation is X divided by 20 plus X divided by 30 equals 1. Now we need to multiply everything by the common denominator. The easy way to find the common denominator is multiply the denominators together. So 20 times 30 equals 600. Okay? So we're going to multiply everything by 600. So 600 times x divided by 20 is 600. X divided by 20 plus 600x divided by 30 equals 600. Okay, well, 600x divided by 20 simplifies to be 30x, plus 600x divided by 30 simplifies to be 20x equals 600. Well, 30x plus 20x is 50x equal to 600. Divide both sides by 50. Divide by 1. X equals 12. All right, it will take the two teams 12 hours to complete the job together. All right, go ahead and finish it up. All right, let's take a look at the next page. Marina is a community volunteer. She volunteers by watering the large vegetable garden in her neighborhood. Sometimes Marina's friend, Sandra Jane, also volunteers. 8. It takes Marina 90 minutes to water the garden. When Marina and Sandra Jane work together, they can complete the job in 40 minutes. A. Complete the table. Let X represent the time it takes Sandra to water the garden if she works alone. All right, portion of the garden water. Marina is 40 times 1 divided by 90, which equals 40 divided by 90 equals 4 divided by 9. Okay, Sandra Jane is 40 times 1 divided by X, which equals 40 divided by X. So the entire job would be 4 nines plus 40 divided by X. Now, Marine, rate of watering is 1 divided by 90, and Sandra Jane's is 1 divided by X, and you can leave that box blank. All right, go ahead and finish the table. All right, B. Write and solve an equation to determine the total time it would take Sandra Jane to water the garden if she worked alone. So that would be 4 divided by 9 plus 40 divided by X equals 1. Now we need to multiply by a common denominator, so the fastest way to find the common denominator is to multiply the denominator together. So 9 times X is 9X. So we're going to multiply everything by 9X. Well, 9X times 4 nines is 36X divided by 9, plus 9X times 40 divided by X is 360X divided by X equals 1 times 9X is 9X. Well, 36X divided by 9 is 4X, plus X divided by X is 1, so that's plus 360 equals 9X. Subtract 4X from both sides. That cancels. You get 360 equals 5X. Divide both sides by 5. 5 divided by 5 is 1. X equals 360 divided by 5 is 72. So it will take Sandra Jane 72 minutes to water the garden alone. All right, go ahead and finish it up. Let's take a look at the next page. Activity 5.2, solving mixture and density problems. A mixture problem involves the combination of two or more substances and the concentration or density of one substance relative to the other. Manuel is taking a college chemistry course, and some of his time is spent in the chemistry lab. He is conducting an experiment for which he needs 2% salt solution. However, all he can find in the lab is 120 milliliters of 10% salt solution. 1. How many milliliters of salt and how many milliliters of water are in 120 milliliters of 10% salt solution? There are 0.10 times 120, which equals 12 milliliters of salt, and 0.90 times 120, which is 108 milliliters of water, and 120 milliliters of 10% salt solution. All right, 2. What would the concentration of salt solution be if Manuel added 80 milliliters of water, 180 milliliters of water? If Manuel added 80 milliliters of water, the result would be 12 milliliters of salt divided by 200 milliliters of water, which equals 0.06, which is 6% salt solution. If Manuel added 180 milliliters of water, the result would be 12 milliliters of salt divided by 300 milliliters of water, which is 0.04, which is equals 4% salt solution. Okay. 3. Write and solve an equation to calculate the amount of water Manuel needs to add to the 120 milliliters of 10% salt solution to make a 2% salt solution. Let X represent the amount of water Manuel needs to add. Okay, so our equation is 12 milliliters of salt divided by X milliliters of water equals 0.02. Okay, so we're going to divide that by 1 and cross multiply. So 12 times 1 is 12 equals X times 0.02 is 0.02X. Okay, we're going to divide 0.02 by both sides. That divides becomes 1. X equals is 600. Manuel needs 600 milliliters of water to make a 2% salt solution. Well, let's take a look at the next page. Tony is working on a chemistry experiment. She has 20 milliliters of a 20% sulfuric acid solution that she is mixing with a 5% sulfuric acid solution. 4. Describe the range of possible concentrations for the new solution. The new solution will be between 5% and 20% sulfuric acid. 5. Suppose that the 20 milliliters of 20% sulfuric acid solution is mixed with a 10 milliliter of 5% sulfuric acid solution. What is the concentration of the resulting solution? The concentration of the resulting solution will be 15%. 6. Write and solve an equation to calculate the amount of 5% sulfuric acid solution Tony added if the resulting solution is 12% sulfuric acid solution. Let X represent the amount of 5% sulfuric acid that Tony added. All right, so our equation is, and this cut off a little bit in the copying, so let me rewrite this. 4 plus 0.05x divided by 20 plus x equals 0.12. Now, we're going to divide this by 1 and cross multiply. So 4 plus 0.0x times 1 is 4 plus 0.05x equals, now we need to multiply 0.12 times this and x, so 20 times 0.12 is 2.4 plus 0.12 times x is plus 0.12x. Okay, now we're going to subtract 0.05x from both sides. So let's go ahead and do that. So 0.12 minus 0.05 is 0.07. So that cancels. You get 4 equals 2.4 plus 0.07x. We're going to subtract 2.4 from both sides. That cancels. You get 1.6 equals 0.07x. Divide both sides by 0.07. This divided becomes 1. So then we do 1.6 divided by 0.07 is 22.9. Okay. So Tony added 22.9 milliliters of 5% sulfuric acid solution to create a solution that consists of 12% sulfuric acid. All right, the density of a substance is its mass divided by the volume of space it occupies at that mass. Water has a density of 1 g per cubic centimeter, and frozen water has a density of 0.934 g per cubic centimeter. If you place a bottle of water in the freezer long enough, it may explode. How could this happen if the density of frozen water is less than the density of water? Model an example to explain your thinking. The density of frozen water is less than the density of water because it fills a greater volume with the same mass. So it explodes, which causes the bottle to explode. All right, go ahead and finish it up. And have a wonderful Wildcat day.